All right, let's dive right into what is essentially a massive scientific detective story about an invisible leak in the Arctic, one that our global climate models completely missed. Welcome to this explainer. Today, we're unpacking a fascinating and frankly pretty concerning piece of research recently published in Nature Climate Change. We're going to look at a vast, frozen region of our planet that is currently warming 3 to 4 times faster than the global average, and we'll explore exactly what that intense heat is unlocking beneath the frost.
So why are boreal Arctic methane emissions suddenly surging? That's the big mystery we're tackling today. Now, we have known for a long time that wetlands are the largest natural source of methane. But how are these freezing, remote boreal Arctic wetlands reacting to a warming planet? Well, thanks to a massive compilation of 2 decades of ecological evidence, we finally have an answer. And as you'll see, the data shows a sudden, definitive surge.
Just to set the stakes here, you really have to think of methane as a supercharged, incredibly heavy thermal blanket. Over a 100-year horizon, it traps 28 to 34 times more heat in our atmosphere than carbon dioxide. So even though there's less of it up there overall, its potential to rapidly accelerate global warming is massive. When a region holding vast amounts of organic matter starts leaking this potent gas, it's a literal global security alert.
Section 1. The Arctic Methane Mystery, setting the scene. The sheer scale of the boreal Arctic is just staggering. We are zeroing in on 2 prime suspects here, the Western Siberian lowlands and the Hudson Bay lowlands. Together, these 2 massive wetland hotspots pump out roughly 53% of the methane emissions for the entire region. Researchers have been out there at various observation sites, meticulously measuring the actual gas exchange between the ground and the air to figure out what's going on.
By feeding 20 years of this hard-earned observation data into advanced machine learning models, researchers scaled things up to look at the whole region. And what they found was a highly alarming 8.9% upward trend in methane emissions since 2002. To put that into perspective, this region is now pumping out over 20 teragrams of methane every single year. And get this, it's not a year-round slow leak either. About 62% of this massive surge happens specifically during the early summer months of June and July.
Section 2. What's driving the surge? Identifying the culprits.
Now, you'd probably think, hey, the ice is melting, so the wetlands are just physically getting bigger, right? Well, here is the big twist in this case. The actual physical footprint of these wetlands didn't grow over those 2 decades. The data showed no significant long-term changes in wetland area. Instead, the intensity of the methane practically burping out of the existing wetlands completely spiked. The exact same patch of ground is simply generating and releasing way more gas per square meter than it used to.
So what is actually cranking up that intensity? Well, temperature is the main culprit, driving a massive 52.3% of that upward trend. The warming basically kicks the methane-producing soil microbes into overdrive. But coming in hot right behind it, driving about 40% of the surge, is vegetation activity. It makes sense, right? As the Arctic warms up, it greens up. More plants mean more organic fuel gets pumped right into the soil for those microbes to just absolutely feast on.
Section 3. The 2016 warning sign, uncovering the smoking gun.
Let's anchor this to something you probably remember, the massive 2015 to 2016 El Niño event. That phenomenon actually altered weather patterns and triggered an intense heat wave all the way up in the Arctic, causing a drastic 2 degrees Celsius temperature spike in the region. And since we just talked about how incredibly sensitive these wetlands are to heat, you can probably guess what happened next. Boom! It triggered a sharp 15.5% jump in emissions compared to 2002. It was the highest recorded methane emission for the region, hitting 22.3 teragrams in a single year.
This right here is our smoking gun. When researchers compared the geographic footprint of that massive heat wave directly alongside the methane spike for that exact same year, the overlap was literally undeniable. The extreme heat matched the location of the methane surge perfectly. It proves without a doubt that when the temperature spikes, the methane just pours out.
Section 4. Blind spots in climate models, a broken security system.
To understand how this slipped under the radar, you need to know how scientists track the global methane budget. They basically rely on 2 types of models. First, we have top-down models, which act like eyes in the sky, observing the atmosphere to estimate where the gases are coming from. Then we have bottom-up models, which simulate the physical ground, the plants, and the microbes to predict what is actually supposed to be released. Both of these systems are absolutely crucial for predicting our climate's future.
But when researchers stacked these models up against the hard reality they uncovered, the failure was pretty stark. The atmospheric top-down models aimed way too high. totally overestimating the emissions. Meanwhile, the bottom-up ecosystem models ran way too low. And even worse than just missing the total amount, those bottom-up models essentially simulated a flat line. They completely missed reality's 9% climb.
The researchers put it perfectly when they stated that current generation models basically failed to capture both the magnitude and the trend of these emissions. And here's why that's a huge deal. If our models don't account for this temperature-driven intensity spike, our global predictions for the future of our climate are severely compromised. By underestimating the current intensity of methane emissions, they are drastically underrating the biogenic contributions to our warming atmosphere moving forward.
Section 5. Why this matters now. The global impact.
So let's look at how this builds into a global scenario that directly impacts all of us. Remember how we said the physical area of the wetlands hasn't expanded yet? Well, as the Arctic inevitably keeps warming, future permafrost thaw is going to cause those wetlands to physically expand. If warming makes the wetlands bigger, while the heat and the new plant life are simultaneously cranking up the emission intensity per square meter, we are looking at a severe, unchecked positive feedback loop. Essentially, a much bigger wetland burping much, much harder. It's a massive multiplier effect, impacting the globe that our current models just are not prepared for.
Which leaves us with one final, absolutely vital question as we wrap up this explainer. If the best climate models in the world completely missed a 9% surge in a gas that traps roughly 30 times more heat than CO2, what other invisible threats are hiding undetected in the rapidly changing north? This new benchmark data is absolutely a huge step toward fixing our models, but it's a stark reminder of just how much we still have to learn about our planet's fragile yet incredibly powerful ecosystems. Thanks for hanging out with me today, and always keep questioning what's beneath the surface.